Hello everyone, I am Neetushri, an electronics and communication student at Sri Venkateswara College of Engineering. I am here today to give a seminar on reliable distributed computing for Metaverse, a hierarchical game theoretic approach under the guidance of Professor Vikas H. Today's contents are introduction, literature survey, methodology, result, applications, conclusion, and reference. Before we get into it, let us know what Metaverse actually is. Metaverse is a virtual universe that is parallel to the physical world in which users interact with each other using digital appearance. It's nothing but a virtual universe, a computer stimulated environment where users can create a personal avatars and simultaneously explore virtual world, participate its activities, and communicate with others. What is meant by reliable distributed computing for metaverse? When a system is considered reliable, which is efficient, if it keeps delivering its service, even one or several of its hardware and software components fail. The main aim of this is to improve computer intensive tasks like matrix operations, image processing, search engine, etc. in metaverse. Next, we go for CTC vehicular metaverse. Coded distributive computing is a technique used in distributive computing system to improve reliability and efficiency. It can reduce the communication load for distributed computing system. Now let us know what vehicular metaverse actually is. It is a digital world where cars and other things are related to for transportations are made to look and act like they do in real world. It can use it to test how car can drive by themselves or how traffic moves in a city. It's like a big video game, but with cars and road instead of characters and levels. Now, if we go for objectives, the first objective it is to demonstrate the effectiveness and scalability of the proposed approach through experimental results in various scenarios, to prove a theoretical foundation for the proposed approach and explain its practical implementation, to explore the potential application of the proposed approach in a various domains such as online gaming, virtual reality, and social networking, to propose a novel approach to distributed computing in the context of a virtual environment known as metaverse, which can address the challenge of heterogeneity, dynamics, and unpredictability of users' behavior and network conditions. Now, if you go for literature surveys, there are many people which explains the same paper in a manner, and every paper has its pros and cons. And first paper, a block-based, secure, and efficient data sharing framework for metaverse applications. And the pros are the blockchain-based framework for metaverse application provides a secure, efficient, decentralized data sharing that is transparent due to the use of blockchain technology. Cons are one potential drawback of this is a blockchain-based framework. It is complexity and scalability issue, which can make implementation and maintenance costly and challenging. Now, next paper, trust and reputation management in decentralization and distributed computing. Trust and reputation management system improve security, reliability, scalability, and efficiency of decentralization and distributed computing. Implementing the effective trust and reputation management system in decentralized and distributed computing can be challenging. Third paper, distributed ledger technology for peer-to-peer energy trading in the metaverse. Now, peer-to-peer energy trading in the metaverse using distributed ledger technology, which can reduce the transaction costs and increase the efficiency, improve security, and create new business opportunity while addressing various technical, economical, and regulatory challenges. And the drawbacks are peer-to-peer energy trading in the metaverse using the distributed ledger technology may face scalability issues, regulatory changes, and adoption limitations. Fourth paper, Game-Theoretical Analysis of Distributed Computing in Metaverse. The paper provides a comprehensive analysis of the game-theoretic model and mechanism that can be used in distributed computing in Metaverse. The implementation of game-theoretic models can be complex and may require specialized knowledge and skills. Fifth paper, a secure and efficient storage scheme for the metaverse based on the blockchain and secret sharing. Pros, it combines blockchain technology and secret sharing to provide secure transport and decentralization storage for metaverse data, which can be accessed only by authorized parties and can be scalable. Drawbacks, the implementation of the proposed scheme may be complex and require specialized knowledge and skills. Uh, Now, if we go to methodology, the framework is designed to address the challenges of resources allocation and task scheduling in a decentralized and heterogeneous metaverse environment. The author uses a combination of game theory, optimization, and stimulation to design and evaluate the framework. The stimulation results demonstrate the effectiveness of the framework in improving the reliability efficiency of distributed computing in the metaverse. The author also evaluates the impact of various factors on the performance of the framework, such as network topology, computational resources, and task allocation strategies. The methodology involves a combination of theoretical modeling, optimization, stimulation to validate the proposed approach. Now, if we go to block diagrams, in the first block, we can see the reputation value. So, what is reputation value? It refers to the perceived person, worth, or a value of an entity, that object that has identity or the system based on their past actions. Now, second, coalitions game, select reliable workers. It is used as it is used to select in selecting the reliable workers and nodes. It involves a group which forms an alliance to achieve the same goal. Now, what is reliable workers? It refers to the nodes, devices, and entities that participate in the computation performance, and they're assigned tasks with no errors or failure, and that will be given to the Stackelberg game. Stackelberg maximize the utilities of MSP in workers. MSP is a managed service provider. It involves a leader. Here, MSP acts as a leader and the follower, which are workers. The leader makes strategies, decision, the followers has to respond to it accordingly. And intensive mechanisms. So intensive mechanism, it is used to encourage the workers to perform the task very reliably. Now, blockchain decentralization management for coded distributed computing in a metaverse. So it is used the network is utilized to manage the distributed computing resources and task in decentralized and in a transparent manner. So all this is given to the coded distributed computing in vehicular metaverse, alleviates stragglers effect and provide fault tolerance. Here, the alleviating straggler effect and the providing fault tolerance are two important challenges in achieving the reliable distributed computing in vehicle metaverse. So, what is alleviate stragglers? It refers to the delay or slowdown in overall computation process due to the presence or slow or underperforming vehicles or workers. Now, fault tolerance, it refers to the ability to the system to continue functioning even in the presence of for failure, such as vehicle breakdown, computation error, or crashes. Now, if you go to results, the results of the study shows that the proposed framework can improve the reliability, efficiency of distributed computing in the metaverse. The hierarchical game theoretic approach can be effectively address the challenge of resources allocation and task scheduling in the metaverse, which are critical for reliability, efficiency of distributed computing. The result also shows that the proposed approach can handle different type of tasks with varying resources requirements, such as computational tasks, data storage tasks, and a communication task. Stimulation conducted on a large-scale metaverse environment demonstrate the hierarchical game approach can lead to the significant reduction in the number of failed tasks and improve the overall system performance. The proposed approach is scalable and can handle an increasing number of users and tasks in a metaverse. Now, applications. Apply the four applications: online gaming, virtual reality, social networking, and e-commerce. The metaverse is increasingly being used for online gaming and proposed approach and can improve the reliability and efficiency of distributed computing in gaming scenarios. Now if we go to virtual reality applications require high quality visual and auditory content, significant computational resource. It optimizes the allocation of resources in the virtual environment, leading to improved performance and user experience. Social networking. The metaverse can also be used for social networking, where users users can interact with each other in a virtual space. The proposed approach can optimize communication and information sharing among users, improving the reliability and efficiency of the social network. E-commerce. The metaverse can also be used for e-commerce, where users can buy and sell virtual goods and services. The proposed approach and optimize resource allocation and conflict resolution among the buyers and sellers, improving the efficiency and reliability of the commerce platform. Now, when we come to the conclusion, it proposes the hierarchical game-theoretic approach for reliable distributed computing in a metaverse environment. It argues that the metaverse, which is a virtual world that is shared by millions of users, requires a reliable distributed computing system to support its complex application and services. The author evaluated their approach through simulation experiment and shows that it achieves a higher reliability and efficiency compared to the existence approach. It also discussed the limitations of the approach and suggests that the direction for future research. In conclusion, the paper presents a novel hierarchy game theoretic approach for reliable distributed computing in metaverse environment, which can potentially enhance the performance and scalability of metaverse application and services. And these are the reference papers which has been explained in the literature survey. Thank you.